All right, my lovely sixth graders. Mr. Pennybags is in the house. He's here to help us acquire some new properties. Indeed. So, this is going to be our notes for the topic, using properties to compare expressions. When we're comparing expressions, we want to be able to rewrite the expression in an equivalent form, so in a form that's equal to the one we originally started with, and the goal is to make the problem easier. All right, let's get started with our essential question. How can I use properties to rewrite an expression? All right, so to start, properties are statements that are true for any number. An expression like 6 times 3 or 3 times 6, they're called equivalent because they both have the same value. In this case, that value would be 18. Now we have 3 properties that we're going to cover in this particular lesson, but it's important to remember it doesn't matter what we're doing to the expression, so how we're changing it, because ultimately it's going to be the same value. It's the same number. All right, we're going to start with our commutative property. So if you have colored pencils or a highlighter, you want to mark that. We have a commutative property, and so it's just like it sounds. We know we commute to school, back and forth to school. We commute to the store. Our parents commute to work. That means you are moving. You are going somewhere. In this case, our commutative property, you're going to see the numbers move. They're going to change their order. So what it states is that you're allowed to change the order of any number when you're adding or when you're multiplying, and you will not change the answer. So you won't change the sum if you're adding, and nor will you change the product if you're multiplying. Notice what 2 operations it works with: addition and multiplication. And the 2 that we left out, subtraction and division, well, they don't work for the commutative property. So I'm going to call those weak properties because they don't work. Weak operations, because we can't do anything with them. If we change their order when we're subtracting or dividing, we get a different answer, which is not what we want. All right, so example would be A plus B. It's the same as if you had done B plus A. So if you had done 2 plus 5, you're going to get the same answer as if you had done 5 plus 2. That is the commutative property of addition. It also works for multiplication, like I stated before. We can do A times B. That's going to get us the same answer as if we had done B times A. So just like in our earlier example, we can do 16 times 4. That's going to get us the same thing, 64, as if we had done 4 times 16. So that's our first property, the commutative property. You've been doing it before. Now we just put a name to it. Next property we need to note is our associative property. I like to think of this one to help me remember is I go at lunch to associate with my friends, just like you do. You go group up with your friends. This property allows you to change how numbers are grouped together when adding. Again, it's only when adding or multiplying, and your numbers will be unchanged. Your value will be unchanged. So when we see this one, example would be A plus B, they're partnered up, plus C on the outside. That would be the same as if we had put A now on the outside, no partner, plus the quantity of B plus C. You're going to get the same answer. Doesn't matter how they're grouped. So we can just put numbers into this, like 2 plus 7. Let's take the quantity of 2 plus 7 plus 3. And we can say that's going to be equal to, now 2 is outside, no partner, and 7 has been paired with 3. Now, why would I want to put 7 and 3 together? Because you know that makes the base 10 number, so 10 itself, and then 10 plus 2 is easy to get 12, as opposed to when you have to do regrouping here with 9 and then 3 for 12. So again, it's just about making the problems easier. You're setting up for the future. So you're starting out easy so that you have the skill to set up for the future. So we see this works also with multiplication. So it'd be A times B. Let's say they're partnered up and C's on the outside. And then A is now going to be on the outside. A times the quantity of B times C.
Ms. Launer, please call extension 45101. Ms. Launer, call 45101, please.
As you can see, it's busy this morning. So let's put some numbers in here. Let's say we were going to do 3 times 1/16. 1/16 times 32. And let's say 3 and 1/16 were grouped together. It would be the same answer, same product we would get as if we had done 3 on the outside times 1/16 times 32. Now I know 32 is a multiple of 16, so when I do this work, it's easy for me to say, hey, answer's 2, and then multiplying 2 by 3 is much easier, as opposed to doing 3/16 and then multiplying it by 32. It's just a little easier, and that's our goal, to make problems simpler, and in some cases in the future to make them possible to solve, because the way they're written may be just super challenging, more challenging than it needs to be. All right, next we have our identity property, and that one states that you're allowed to add 0 to any number or multiply by 1 and the number will stay the same. So we see that in an example of like A plus 0 gives us A. So if you had done 4 plus 0, you'd still end up with 4. Also, it's in multiplication. You can do A times 1 and you'll still get A. Like when we see 6 times 1, we still get 6. Now, how is this helpful? Like in the future, when they try to get tricky, they'll do something like 12 times 3 over 3, which you know is just a fancy way to write 1, and you get 12 again. And that'll help us if we just like need to change the format of how we see a number, so we can then do something further with it. Now, to a test-like question. Determine whether the expressions are equivalent. If so, tell what property is applied. If not, explain why. So we're getting to our being able to construct viable arguments. We need to be able to explain why certain things work and others don't. So we have a list here so we can practice later, but we're going to do our work on this section. So you'll see me write in this section. All right, our first one was 7 times the quantity of 3 times 2. We're comparing that with the quantity of 7 times 3 times 2. All right, as we see this, I didn't bring my highlighter in here. Bummer. That's okay. As we can see, I'm looking here and 3 times 2, they're grouped together, whereas 3 switched partners and became partners with 7. When I multiply this, it would be 6 times 7 for 42, and this would be 21 times 2 for 42, because they have the same value. Excuse me, they are equivalent, and the reason is we can see that the associative property was applied. We know that it was a grouping change. All right, next. Looking at it, we have 16 divided by 8 and 8 divided by 16. Well, 16 divided by 8, 16 divided by 8 gives me 2. And 18 divided by 16, 8 divided by 16 gives me 1/2. Those are not the same values. 1/2 and 2 are not the same values. So this is not a property. Even though we can see they changed the order, division is not commutative. So this would not be an example of a property because indeed they're not equivalent expressions. Next up, we have 16 plus 0. And as I can see, I'm adding 0. Whenever I'm adding 0, it doesn't change the value. So these are equivalent. And this will be by our identity property of addition, if you want to be specific. And then finally, we have 32 plus 4 and 4 plus 32. 32 plus 4 is 36, and 4 plus 32 is also 36. We see that 32 has just switched places, and because they have the same value, they're equal to each other, and the reason would be they applied the commutative property. and we saw an order change. Well, it is starting to get busy here this morning, so it's perfect that we've finished our notes. If you have any questions, come see me in class.